So friend, today we are going to learn about this how to read this schematic diagram and what are the test points of this Lenovo 100E model. So I open here a concept of this Lenovo 100 model. This diagram is a 46 page diagram, and I'm going to explain you how to diagnose the problem and how the type C circuit works in this laptop's motherboard. Okay. So, but before that, we first go back and understand the concept of the Type C controller, power delivery systems, and buck boost converters. So the in this concept, so you can see here are the two power inputs. You can see this is a one power inputs, and here is a another power inputs for the power delivery. So this is a two power. You can connect the power here, and either you can here or here, anywhere where you want. You can connect the power, and then the power meet here together. So that means this is the junctions. So the power, the V bus voltage will pass either from here like this, cross this MOSFET and come here, or it will come from here, then cross this MOSFET, Q means MOSFET, and then come across here, and that voltage is your system voltage. Okay, and this is the buck boost converter. Buck boost converter is a circuit. Basically, buck means decrease the voltage or reduce the voltage, and boost means increase the voltage. So what the boost converter do? Increase the voltage. When the voltage going from this side, from the adapter connector side, then it's a buck converter. That means reducing the voltage. That means this 20 volt he convert into 13 volt. Okay, and the boost converter means the system voltage is going to the toward the connector, that means toward the adapter side. At that time, this buck boost converter boosts the voltage. That means voltage coming from this point, and it switches and going output, and then it goes output. Okay, so voltage either coming from this side or from the this side. So here is a buck boost converter chips. Here are the two MOSFET. When the voltage coming from this side, then two MOSFET, this two MOSFET started switching, and voltage pass to this L1 coil, and then this Q3 will pass the voltage and come across this capacitor. Here you will get a DC voltage, that is 13 volt. Okay, and voltage is coming back to the connector. At that time, these two MOSFETs are started switching, and then the pulsating AC voltage passed this coil. Then this Q1 MOSFET will be turned on, then the voltage go reverse and goes to the connector either here or here. So here are the two power inputs. That means when we connect the adapter from here, the CC bus detect the power, and then the voltage is come across this MOSFET, and then this there are two individual type C controller chips. Okay, each type C controller chips for the each ports. Okay, so when it detect the powers, when we connect the adapter here or here, it detect the power, and accordingly he drive this MOSFET, this load MOSFET, and then the voltage pass here to here, or if we connect the adapter, then they drive this MOSFET, and the voltage will pass from here to here. Okay, and then this voltage goes here. Then here is the buck boost converter chips, which receive the power, that is a DC in or the VCC, or it's called the V bus. This V bus voltage going into the chips, and here is the two resistor divider circuit which detect the voltage, that is called the adapter current in. Okay, and that is supposed to be 3 volt. When this 3 volt receive this buck boost converter, then these chips generate ACOK signal, and that ACOK signal is going to the SIO. Here is the SIO. Okay, so SIO receive this voltage. If the pro hot signal will be generated, this voltage will be terminated. The pro hot signal should not be generated, it should be enabled. Okay, then after, here is the buck boost converter and the SIO started communicating with each other via this I2C bus, and then what the buck boost converter do is he started switching this two MOSFET, and then this 20 voltage will pass to this coil, and then this Q3 will be turned on, and the voltage pass across the capacitor and goes into the system. When the battery is connected, when the battery is there, at that time the battery and this buck boost converter started communicating with each other, and then if the battery needs a charge, then this 30 voltage come here, and then this chip will drive one signal that is called the battery drive signal, which drive this Q5 MOSFET, and the battery adapter voltage will pass here, pass through this R2, this is current sensing resistor, and come across into the battery positive terminal, and then the battery started charging. When we remove the adapter from the both the side, we suppose we don't connect the adapter here or here, then the battery voltage, that is a 13 volt, will be passed through this Q5 MOSFET, and then this voltage will come across here and goes inside the computer system, that is called a system voltage. That means voltage either coming from here or here, or voltage coming from the battery to the system. So okay, so this is a concept of the buck boost converter. So in this way this circuit works. So now we'll go back into the schematic diagram and we'll see how the things are work. So here is a schematic diagram which is a 46 page. So the first will scroll down. So these are the Apollo like processor, and here is a power delivery system. There are two power inputs. Okay, there are two power inputs, and there's a buck boost converter which receive the voltage. Okay, so now we'll go to the first connector. We'll scroll down and we'll see where is the connectors. So here is a connector. So I'll zoom this connector. So you can see in this connector. So this is a type C controllers connectors. Okay, and this connector location is a J13, and you can see here's a V bus. So this is a V bus B4 and B9. So this is a V bus. There will be four V bus. Here also V bus. Here also V bus. So all V bus are connected. V bus means the power. Okay, and then there is one line is called the CC line. So you can see here will be a CC line. So this is a CC line at B5, CC2, and there will be CC also, CC1, here also CC1. So these are the CC connectors. Okay, so CC is a configuration channel where he detect the power and started communicating with the adapters. Okay, so this, when we connect the adapter, then the CC line communicate this. If the 5 voltage is there come, that means that is a sender, and if it is a 0 volt, that means it is a receiver. So when the adapter is connected to the CC line detect the power, and then adapter and laptop communicate via this CC line, and there is a controller chips that is called a type C controller chips. So that type C controller chips receive this CC line. So that information in page number, okay, this page number 31, you can see this chip number is U16. So this is a chip number is U16, and the chip name is ANX3429. Okay, this is a QFN chips. Okay, and CC line is connected. So this port, so this is a connector port. So all this signal is going this side. So this is a connectors. So you can see here there's a CC line, CC1 and CC2, then P and RXN, that is a received, and TXP and TXN, that is a transmit. So there are two transmit, two receive signal which is connected to the connectors and CC line, and then SBU signal, and of course there is a V bus signal. So this is a V bus signal. So when the CC line will detect this signal, then he drive the MOSFET. So where are those MOSFETs? So we'll go and see where are those MOSFET. So we'll scroll down. So you can see the chips, and these chips require a basically 3.3 volt power to run. Okay, so here is a supplies is there, DVDD supply. So 3.3 volts require these chips to work, and then is I2C bus. I2C bus start communicating with the SIO. Okay, and this side is basically is a communication PCI Express ports which is communicating directly with the CPU, where when the transmit data will be received here and sent to the CPU, and when the CPU send the data, that will be sent to this connector and is going out. So this chip is a basically is a control and manage the type C controller port. Okay, so this side is a PCH side and this side is a connector side, the power side, and then the power delivery system. So the next is we'll scroll down and we'll see where is a buck boost converter. So here is a buck boost converter. Now you can see in this side, so you can see this is the buck boost converters. Okay, this is a buck boost converter. So here are the two MOSFET, and the voltage is coming from this side, type C port 1, and this is a type C port 2. Suppose this is a 1 and this is a 2, and these are the load MOSFET which drives and controlled by the type C controller chips. And here is the junction. So this point is a basically a junction, the voltage coming from either from here or from here and meet together, and here is a current sensing register. Then voltage passes to the this upper MOSFET, started switching, and here is my output system voltage. Okay, so this is a system voltage is going to the inside into the laptop, and this is the battery. So this is the battery connectors, okay, which is going to, and this chip is a control and manage all this four MOSFET as well as this battery controller MOSFET. So here is our port. So we'll zoom and we'll see. So this is MOSFET number PQ1 and PQ2. When the adapter voltage come across here, then this PQ1 and PQ drive this voltage and pass via this two MOSFET come across here. So which signal is going to control this MOSFET? This signal name is USB-C0 VBus underscore in underscore gate. So we'll see from where this signal is coming. For that, what we have to do is we have to select this and we'll copy this signal. Then we'll come here, find, and then we'll paste, enter. So you can see on page number 33, on page number 30, the U16, this chips drive this signal. So this chip is only drive this signal, U60. So this chips drive this signal and receive the voltage. Okay, receive this voltage, USB-0 VBus in underscore gate, and there is another port is called USB-C1 underscore VBus underscore gate, that is voltage coming from the another port. So is coming from this port. At that time this signal will drive when we connect the adapter to the another port. So that is, so this is a power USB. So we'll see from where this this voltage is coming. So there are two port. One is this upper one, and there is a lower one. So there are two connectors. Okay, and here are the Q3 and Q4 MOSFET. So when the voltage will travel from here, so when the gates are dry, at that time the voltage will pass from this drain to source and here, and then goes here and come across here, and so this is a junction. So this is a input signal to the buck boost converter. So here you should get a 20 volt. How much you should get? A 20 volt, and that voltage either coming from here or coming from here. It's a depend where you connect your adapter. So you have to see that. Okay, and if the voltage is stuck here, suppose you connect the adapter over here, and suppose your 20 volt is coming here, but 20 volt is not coming here, that means this MOSFETs are not driving. So now this MOSFET are n channel MOSFET, this PQ1 and the PQ2, these are the n channel MOSFET. So here you should get a positive voltage. So this signal is coming from this chips. So you have to see why this chip is not sending this signal. So you have to select, you have to see this V bus input signal, why the V bus input signal is not detecting. And here is a port, it's called the I2C port. The I2C port is basically as a communication port which communicate with the type C controller chips. Okay, and the type C controller chips tell this buck boost converter that from where the power is coming in. Okay, now we'll come to the type C controller chips. So here is the type C controller chips. So type C controller chips, the location of the type C controller chips is U60. Okay, and the chip number is BD 99954. So this is the chip. Okay, and then so the chips get the power from pin number 1 and pin number 2. The pin number 1 and 2, you should get a 20 volt at here, and then this chip will, once the chips get the 20 volt, and then after this chip will drive a 6 volt output. So at this REGN pin you should get a 6 volt output here. So you have to check that 6 volt, and then you will get a pin number 6 and 7 20 volt, and here is a port I2C port, and then here is the output signal, is called the adapter current OK signal, and that signal drive output to the SIO, and as well as to the there is another signal is called the pro hot. Okay, so this signal will be dry. After that, once this chips receive this 20 volt and AC OK signal will be generated, after that is started communicating with the SDA and SCL. SDA and SCL is basically clock and data, is a I2C bus communication, and then this chip will started switching this MOSFET, this started switching this pulse, generating the pulsating to the MOSFET, because here is a 20 volt, here is a 20 volt, and started switching this MOSFET, and here is a L9 coil, the pulsating AC voltage will be passed, and then after what the chip will drive, this chip will drive this signal and turn on this Q7 MOSFET, and then this pulsating AC voltage will be passed here, and here are filter capacitor C301 and C302 which filter the output voltage, and you'll get your PPVAR, that system voltage, and that voltage approximately 13 volts. So here will be the output voltage. So this voltage is supposed to come. So you can see now in this concept that on this side, this side you are getting a 20 volt, and that 20 voltage will be passed to this current sensing. So here is a current sensing resistors, and then this 20 voltage will be passed, come across here, and that 20 voltage started switching, and then that 20 voltage will be converted into 13 volt, and that 13 volt your system voltage. Okay, you understand? And if this 13 voltage is not coming, then and this 20 voltage is coming here, then you have to go back into this buck boost converter U16, and you have to check VCC, VBus, then AC in, AC OK signal, pro hot signal, and SM bus, this I2C bus. If all the signals are okay but still it's not driving the signal, in that case this chip probably faulty, or these two MOSFET probably faulty. So you have to replace and check. Now the next thing is battery, how the battery voltage will drive, how the battery charge. So here is a Q72 is a MOSFET who is responsible for the battery. So this 13 voltage is going to the system, that is output, and here is a another current sensing resistor R401 which is connected to the this Q72 MOSFET, and the Q72 MOSFET source is connected to the battery terminal. So here is the battery terminal. Okay, so this is my battery terminal, and here we should get a 13 volt and which drive the output. So when the battery needs a charge, at that time this signal will be drive to this gate. So this is n channel MOSFET, and this signal name as charger charger B gate, and this charger B gate is coming from pin number 28, and this going signal out to this gate, and then the battery started charging